Good morning, grade 11s. As you can see by the background behind me, I am at school. I will be doing a video on rational expressions today. It's your next unit. Now this is going to be a little different because Mr. DeVries' class has already done this. So if you are in Mr. DeVries' class, you will not need to do my rational expression stuff at all. My class, you will find that stuff in the stream, rational expression, Mr. Myers' class, or whatever. And I'll put all this in the stream as well. Okay? So, without further ado, let us get down to the first lesson on that. And here we are. It is page 163 for Mr. Myers' class. And we will begin in a moment. I just gotta find my magic pen. Just like class. Alright, here we go. So, before we go on, let's discuss what a rational expression actually is. But before we can, well, no, we'll do that right here. So it says it's an algebraic expression. If it says algebraic, we know there's variables involved. So it is an algebraic expression that can be expressed as a rational number if, and that's a big if, the variables are known. Now, so that's all well and good, right? We can say that it's got to be a rational number, but it's not very helpful if you don't remember what a rational number is. So let's take a quick moment to discuss that. Rational numbers have a certain form. So I'm using variables because I say they can be any number. All right, so x and y are integers, and y can't equal 0. Now you have to remember what an integer is. An integer is, you guys would call it a whole number, but that's not right. An integer is -3, -2, -1, 0, 1, 2, 3, up and down to infinity. No fractions, no decimals. So some of you would say, all right, Mr. Myers, well, then we better see some examples because I don't really get what you mean. So a rational number, we'll start with the easiest one. 7. How is 7 a rational number? Well, 7 is actually 7 over 1. Both are integers, no problem. Okay, well, what about 7 over 8? Both are integers, no problem. So then somebody would say, all right, what about 7.1 divided by 8.2? Well, that's really 71 over 82. Both integers, no problem. The square root of 4, no problem, because that's 2, which is 2 over 1. So all of you should be pretty good with rational expressions now, or rational numbers. Now let's make this an easy rational expression. X over 7. No matter what x is, this is a rational number, because even if x were 0, 0 divided by 7 is 0, and that's okay. All right? If x was 1.2, then it would be 12 over 17. 12 over 7. So it's all good. No, it would be 12 over 7. I was right the first time. Anyway, so everybody should be cool with rational. It shouldn't be too difficult. Now let me give you one that's slightly more difficult. X plus 1 over x minus 1. Now, that is rational sometimes. And that is the crux of this unit. Okay, so let's talk about what isn't rational. We already know some. Pi, not rational, doesn't repeat, doesn't end. Square root of 2, doesn't repeat, doesn't end. Square root of 3, cube root of 4, all those are irrational. Now there's some other rules. For example, 7 to the x. This you have to be careful about because it's only rational in one case. So you got to be careful about that. Same with this one. That's not rational because no matter what x is, this number isn't going to end. So you got to be mindful of that. And then we get into this situation because this is sometimes rational. Now let me show you what I mean. I'm going to highlight this word, non-permissible value, which I'm going to abbreviate as NPV. Non-permissible value is any value, and that looks like value, make that a V, any value that makes an expression irrational. And the number one way we find an irrational value is if the denominator equals 0. That's not allowed because we can't divide by 0. So up here, this situation here, we only have to look at the denominator. And if x equaled 1, then 1 minus 1 would equal 0, and we would have had 2, sorry, we would have had 1 plus 1 over 1 minus 1, which would equal 2 over 0, which is irrational. So, non-permissible values, the place we check are denominators. So, let's have a look at these three and see. Now, this first one, there's 3 values there. So we got to identify anything that's non-permissible. T, can T be any number? Even if T is 0, it's okay. Right? 5 times 0 is 0. 0 divided by anything is 0. So T can be any number. So we write that as T with the fancy E that I showed you in grade 10. R for real numbers. Easy peasy lemon squeezy. Now, S. Can S be any number? Any number except 0. Because 4 times 0 would make the bottom 0. So S cannot equal 0. And R cannot equal 0. Pretty easy. Now, it gets more difficult, of course. We look at the denominator, and we see that denominator has 2 factors. It has factor 1 and factor 2. Now, we know that factor 1 times factor 2 cannot equal 0. So if x was 0, what would I have? I would have 0 times 2 times 0 minus 3, which would be 0 times negative 3, which would be 0. So x cannot equal 0. Meanwhile, on the other side, 2x minus 3 can also not equal 0. Because if 2x minus 3 was 0, then I'd have 0 times x would be 0. So 2x minus 3 can't equal 0, so 2x can't equal positive 3, because when I bring that over, so x cannot equal 3 halves. So all you do for these is you make sure that factor 1 can't equal 0 and factor 2 can't equal 0. Okay? Now let's come over to this one. Again, I only look at the denominator, but wait, it doesn't have factors. So what do? We factor it. This, of course, becomes p plus 3 and p minus 4. And there is factor 1 and there is factor 2. So factor 1 cannot equal 0. So p plus 3 can't equal 0. So p can't equal 3. Hey, Arlen. Hey, Arlen. I'm well. You? Factor 2 can't equal 0. So p minus 4 can't equal 0. So p can't equal 4. So those are our non-permissible values. Now there's other stuff going on, but that's the first step. We can never have that. So let's slip over to the next page. Simplify a rational expression. So simplify a rational expression. Let's write one up here that's just numbers, no variables. So let's do 336 over 60. Now, if I wanted you to simplify that, you would all divide, right? You'd break it down. Oh, 2 goes into both of them, 60. So that would give me 2 times 100 and 168 over 2 times 30. Oh, hey, 2 over 2, cancel. So now I've got 168 over 30. Well, that's 2 times 84 over 2 times 15. Oh, cancel. All right. 84 is 3 times 28 over 3 times 5. Well, 3's cancel. And 28 over 5 is our final answer. So you can do this with numbers. It's the same thing with rational expressions. When a rational expression in simplest form, the numerator and the denominator are factored and any common factors are removed. Now I'm going to pause for a second, let you think about that for a minute. Read that. Wow, it went away. Read that. Let's do that one more time. Start with an easy one. 40 over 8. Now, 40 over 8 is 2 times 20 over 2 times 4, which is 2 times 2 times 10 over 2 times 2 times 2, which is 2 times 2 times 2 times 5 over 2 times 2 times 2, right? Cancel, cancel, cancel. What's left? 5 over 1, because 40 divided by 8 is 5. Everybody good? All right, let's go. Simplify each and be sure to identify non-permissible values and highlight them in yellow. All right, so step 1, factor, factor, factor. So, does the numerator factor? Sure, 3x minus 2. Does the denominator factor? Sure it does. You have to remember how to factor these, whatever you like. I, of course, like to do the, there's lots of ways to do it. So I'm just going to go ahead and factor it as 2x minus 5 plus 5, and x minus 2. So that is 2x squared plus minus 4x plus 5x minus 10. Yep, done. So that is step 1, factor. Step 2, NPVs. So remember, for NPVs, 2x plus 5 cannot equal 0, 2x cannot equal negative 5, x cannot equal negative 5 halves, and x minus 2 can't equal 0, so x can't equal 2. That's step 2. And step 3, cancel. X minus 2 on the top, x minus 2 on the bottom. So our final answer is 3 over 2x plus 5. Now some of you will say, well, Mr. Myers, why don't we just check for our NPVs here? Because if x was 2, up here, it still would have been 0. 2 squared is 4, 2 times 4 is 8, plus 2 is 10, 10 minus 10 is 0. So you've got to check your NPVs before canceling. So let's come over to here. I've got 1 minus t over t plus 1, t minus 1. Now, so then we check our NPVs. T cannot equal plus or minus 1. Now, this gets a little weird. Is there any canceling there? I'm going to pause it. You think about it. Okay, look up here. Can I factor out a negative 1 up top? If I did, I'd have negative 1 times t minus 1. Right? Because negative 1 times t is negative t. Negative 1 times negative 1 is positive 1. And then I've got t plus 1, t minus 1. Now look, cancel, cancel. And my final answer is negative 1 over t plus 1. Alright, we're going to do 2 more. I lied. We're going to do 3 more. And then I'm going to leave you guys with your work. So, step 1. Factor, factor, factor. We already know what that is because we just factored it right above, right? 2x plus squared plus x minus 10, 2y squared plus y minus 10. So we already know that that is 2x minus 5, and, y plus 2, 2y over, factor that, we know that's y plus 5, that is y, plus 5 and y minus 2. That's 2x plus 5 and y minus 2. So there we have it. It's factored. To check our NPVs, y cannot equal negative 5 and y cannot equal positive 2. We've seen this a lot. We saw it in quadratics. We saw it all over the place. We've done this to death. Then number 3, cancel. Gone, gone. 2y plus 5 over y plus 5. Some of you will want to cancel this, but you cannot, because this is 2y plus 5. It's not the same thing. And all you have to do to recognize that is, sorry, my computer's about to die, ladies and gentlemen. I just got to slide over to a plug. I'll keep talking. The way to check that, to understand the difference, is sub in a number. What do you mean? Well, what I mean is, if y equaled 5, then I would have 2 times times 5 plus 5 over 5 plus 5, which would equal 15 over 10, which would equal 1.5, right? Now, if you cancel that, which some of you are going to try to do, even though I'm telling you right now that you cannot do that, some of you are going to try to cancel this. You're going to try to do this, which would mean your answer would be 2. Well, does 2 equal 1.5? No, that's why you can't cancel there. So then some of you will say, okay, Mr. Myers, I got you. But you will try to do this. You will try to cancel those. And I'll choose a different color. That will give you 2y over y. Again, choose y equals 5. That is 2 times 5 over 5, which is 10 over 5, which is again 2. 2 is not 1.5. You can't cancel this way. Okay? So, let's get back to where we were. Factor this. Now, remember, I like to change this order to have the m first. Negative 2m plus 6 over m squared minus 9, which I then factor to negative 2m minus 3, because negative 2 times m is negative 2m. Negative 2 times negative 3 is positive 6, over m plus 3, m minus 3. So we do our MPVs. M plus 3 can't equal 0, so m can't equal negative 3. M minus 3 can't equal 0, so m can't equal positive 3. And then we cancel. Cancel. Negative 2 over m plus 3. And there's our final answer. Now we'll do the very last one. Now, most of you, when you see this, make the egregious mistake of immediately substituting in here without simplifying first. So, always simplify first. So that, factor, 4x plus 3y over 4x minus 3y over 2 4x minus 3y. Okay, check our NPVs. 4x minus 3y can't equal 0. 4x can't equal 3y. X cannot equal 3/4 of y, right? And by the same token, negative y, 3y cannot equal negative 4x. So y cannot equal 4/3 of x. Then cancel. Gone. 4x plus 3y over 2. And now that is when you sub in. And it's way easier. So that's 4 times 2.6 plus 3 times 1.2 all divided by 2, which is 10.4 plus 3.6 over 2, which is 14 over 2, which is 7. And then it's done. Now, your work, you finish page 165 and 166 and 167. The answers are all on page 168, and that's where you stop. Okay? Talk to you soon. You're going to have a test on quadratics on Wednesday. So this should be done for Friday's video. Done before Friday. Alright, it's not for marks or anything, it just needs to be done. Wednesday will be your test. Thursday, nobody will probably show up for the meeting. So Thursday, instead of doing the meetings, I will probably post a video going over the test, which means you can't do it if the video's been posted. Okay? So Friday's video will be rational expressions. Thursday, I'll try having meetings. Nobody will show up, so I will do a video of the test on Thursday. So that test, I'm going to make that test live Tuesday night after I've had my Tuesday meetings. Wednesday will be no video, and you'll work on the test. Thursday, I will post the key to the test. So you have all day Wednesday, and I'll make it. I'll make the test available Tuesday evening. So you have Tuesday evening, all day Wednesday, and I'll be posting a video Thursday morning with the key. All right, and Friday is your next video on anything on new material. All right, talk to you soon. All this will be in the stream. You can read it later. Okay, bye-bye.